Welcome to NEET Direct program by SP Smart. Today we shall discuss the previous year questions taken from various competitive examinations from the chapter of gravitation part 2nd. So let's start from question first. If Earth is 1/4 of the present distance from the Sun, the duration of a year will be? Well, it obviously is a question based on Kepler's third law of planetary motion. I'll write this twice and take the ratio. This is what you get now, right? It's T2 by T1 is R2 by R1 power 3 by 2. Now put the value. Distance now is 1/4 of the present distance. It is 1/4. This is the original distance. It is now this is 1/4 of that distance. This is cancelled. This is 1 by 4, which is 2 square, and now this cancels. 1 by 2 cube. It is 1 by 8. On the left hand side you have T2 by T1. You have T2 by T1, so T2 is T1 by 8. That should be the answer. It means that in case it happens that distance of Earth from the Sun becomes 1/4 of the present value, the duration of time will be 1/8 of a present day, and 1/8 means option B is the correct option for this question. So option B says 1/8 of the present. So option B is the correct option, right? Okay, now let's move on to question second. Read the question carefully. Suppose the gravitational force varies inversely as the nth power of the distance. That is, instead of saying that F is proportional to 1 by r square, which is a fact, है ना, gravitational force यही है ना, inverse square law obey करता है. The question says this is not true. In fact, it is r power n as per the question. ये लिखा है यहाँ पे. Then if the planet is moving around Sun in a radius r, the time period will be proportional to, यानी इस फॉर्मूला को मॉडिफाई करना है, बिकॉज दिस फॉर्मूला developed because of this inverse square law. Now inverse square law has been abolished, so ये भी चेंज हो जाएगा. तो क्या बनेगा? This is what we are supposed to find out. Okay, let's see. When the planet is moving around the Sun, the centripetal and centrifugal forces should be equated. Centripetal रहेगा mv square by r, and on the other hand centrifugal जो है वो, well I think I should write capital R here because data में capital R use किया गया. Okay, so this is the force which balances the gravitational force. This is the formula for gravitational force. Now it is as per not inverse square law but r power n. This is what the question says. Now you simplify, and velocity ये क्या है? Circumference by time. b square का मतलब square of this into 1 by r, gm by r power n. Keep on simplifying. 4 pi square r square by tr equal to gm by r power n. You can further simplify. As you can see, this r gets cancelled, and now you cross multiply. And gmt will be 4 pi square rn plus 1. Why plus 1? Because here you can see you have r and this r power n. When both get added, it becomes r power n plus 1. So you have r n plus 1 into 4 pi square. This is equal to gm into t. Further let's check it out. That you have now. So let's move on, simplify it further. 4 pi square by gm r power n plus 1. Now square both sides. T square is equal to 4 pi square by gm r n plus 1 whole square, right? And see what you get. Rather, I should say you take square root on both sides. So it is 4 pi square gm r n plus 1 square root. Since this whole stuff is constant, leave it. You have t proportional to r power 1 n plus 1 whole power 1 by 2 It means t is proportional to r power n plus 1 by 2. So this is the option for this problem, r power n plus 1 by 2 and r power n plus 1 by 2, option A. So option A, which says r is proportional to n plus 1 by 2, is the correct option for this problem. Since there was a little bit of complication, I'll tell you again. As per this question, we have to use centrifugal force, which is suffered by a planet, equal to this, and the centripetal, which is the gravitation force. It has to be like this because लिखा गया कि nth power r की इसमें involved है. So when you simplify it, it is 2 pi r by t whole square, and what I mean, I'm talking about this v square divided by r. It is gm by r power n. You simplify, it becomes 4 pi square r divided by t square, because मैंने इस r को एक r यहाँ से हटा दिया, cancellation हो गया, and now it becomes like this. Cross multiply, you have r power n plus 1 whole into 4 pi square divided by gm, which on simplification gives us the t proportional to r power this, and therefore you take square root, it is r n plus 1 by 2. This is the option I chose, which is option A from this problem, right? Okay, let's move on to question third. A body of mass m is taken from Earth's surface to a height h equal to radius of the Earth. Increase in potential energy कितना होगा? This is what we have to. Well, it's quite simple. Work done in moving a particle from one point to another against the gravitational forces given by this formula. You start putting the values. It is gmm by r1. It is on the surface of the Earth, so it is r. Now it's taken to another height h above Earth's surface. The total distance from center of Earth becomes now 2r. I can show you here what I mean. This Earth, and this is the radius of the Earth. Fine. And now particle is raised to another height r. So the total is 2r. This is the final distance from the center of the Earth. Initially it was only r. That is why r1 is r and r2 is 2r. Right. You simplify it further. It becomes gmm. LCM is 2r. 2 minus 1. It comes to be gmm by 2r. Little bit of trick, because the answers are in terms of small g, so I cannot use capital G here. I multiply with r and divide with r and see what happens. I use gm by r square as a separate entity. ये कितना बनेगा? gm by r square separate कर लिया हमने, and this m, this r, this 2 are written separately. And as you know, this thing gm by r square, this is small g, it is m r by 2, so ultimately it is half m g r. This is the work done, rather this is the increase in potential energy, increase in potential energy. So which option is it? Option B. As you can see, option B says it's half mgr, and this is what we got here, half mgr. So I put here option B as the correct option for this problem. Okay, in this way we have finished today's NEET direct program discussion from the previous year questions taken from various competitive examinations from the chapter of gravitation, part 2nd. Question 1 has option B as the correct option, question 2 has option A as the correct option, and question 3 has B as the correct option. That's all for today, and God bless you all.